8:30. And so I want to introduce to you my friend Craig Kolodge. Craig, you and we've known each other for quite some time now.
We sure have. Yeah.
And Craig is a wonderful person, very knowledgeable when it comes to compost. He is who I call Mr. Compost. He is all about compost. And Craig, I'm going to just now become a silent co-host. I'll watch for questions that anybody might have during your presentation. But why don't you introduce yourself, give a little bit of your background, and it's all yours. Thank you, Craig, for being a part of this morning.
Thank you, John. Thank you so much, and welcome everybody, and really appreciate you tuning in to a presentation on one of my favorite subjects, compost blankets. And it's amazing how often people don't understand what's meant by that. So we're going to get into that very shortly. But my background, if you see that FUD PhD behind my name, I was trained in plant pathology. I worked for the University of California as a farm advisor in Santa Clara County for a lot of years, ran the Bay Area Research and Extension Center, and got involved in compost, gosh, going back over 20 years ago, and its utilization within Santa Clara County. It was a program called Santa Clara in partnership with agriculture program, where we were teaching people how to utilize this very valuable bioresource. And so what we're going to be doing today is we're going to be talking about that soil-water connection, watershed management, how you can use these blankets to really bolster your effectiveness in terms of stormwater management. So let's start with what is a compost blanket. And this comes right from the US EPA's presentation. I actually have a little presentation and I'll show it to you later, but you can email me after the presentation and I'll be glad to send you a digital copy. And it's a compost blanket is a layer of loosely applied composted material placed on soil in disturbed areas to reduce stormwater runoff and erosion. It's typically a 1 to 2 inch layer, can be 3, but 1 to 2 inches ideally. And we'll talk about why that depth of the blanket. A blanket is just something you lay over the top of a surface of something. So in this case, it's loosely applied. It doesn't have any materials in it. And it's an erosion control BMP, best management practice, that is focused on source control. What do we mean by source rather than sediment capture? Erosion is preventing the detachment of soil from the surface. Sediment control is once the soil particle has been detached, we want to capture it. So those are two very different processes for stormwater management, and we're going to be talking a bit more about that. The BMPs, to be truly the best, must be sustainable management practices. And what do we mean by sustainable? In this case, they're practices that meet our present needs without compromising the ability of future generations to meet their needs. That in its simplest form. It requires more of a preventative and proactive environmental design and management rather than a reactive end-of-pipe solution, meaning we're waiting for something to happen and then we react to it. In this case, we're trying to anticipate issues that may come up in our management practices. Biomimicry then is the foundation of all sustainable management practices, and that is the closer we mimic nature, the better off we are. It's an environmental problem-solving approach. It requires, you're looking for no waste. We're looking, in this case, for stormwater, for biofiltration and water absorption, volume control. If we can control the volume of water, we control the contaminants coming off of a surface. It's excellent as a post-fire remediation because of all the toxins released after a wildfire. Green infrastructure, creating habitat, growing things. Plant material is by far our best erosion control. It not only holds that soil in place, but it feeds a wide array of biodiversity in the environment. Native plant animal maintenance, there's that biodiversity, and restoring natural carbon cycles, carbon sequestration. We're not going to go a lot into that today, but it's a very key component, and why we're going to see bills like Senate Bill 1383 that are mandating by 2022 that every city in the state of California has to start diverting their organic, well, they're already diverting some, but they need to hit by 2025 a 75% diversion goal, meaning that material that's now going to landfills and being buried, producing methane and other volatiles, VOCs, has to be diverted and utilized on a local level. So that's why this is an important topic and why you're gonna see more and more of it in the future. And let's look at a natural system, because we talked about mimicking nature. This is what nature does to control and manage the quality of water intuitively. You've got a layer of organic mulch on top. Nature itself produces its own compost, and it produces that layer of organic matter, then that feeds the topsoil, and below that, and as that water runs off, it's filtering this. You do get some evapotranspiration, but note the big circle in there. That is the life in the soil, and we're going to talk a bit about how important that is. So if you look at a hydrology model of a natural system on the left, as we move towards a more urbanized environment, we get into more impervious surfaces, and our pollutant loads automatically go up, and we end up with water impairment problems. Natural capital is the stock material within our environment, which we rely on to provide a steady flow of services necessary to maintain economic, environmental, and human health. Compost is a capital that we can use, and it's extremely important to our very survival. There is no single solution to declining soil and water quality that's better. But the most promising tool for this task is recycled organic matter, and the most versatile organic material is certified compost, and we'll talk a little bit about that shortly. Compost utilization permits the watershed manager to leverage the power of the soil and that water connection. We're, again, mimicking nature. Certified compost, what is that? It's a mixture of organic matter as from landscape waste, food waste, animal manures that has decayed, and has been digested by organisms, been laboratory tested to meet minimum standards of quality, and is used to improve water filtration and infiltration, soil structure and biology. Very, very important. Not all compost is created equal. You want to work with people who have tested that and can provide you the test results of the material that they're providing you. There are two tools when it comes to compost and stormwater management. They're both compost. The one on the left you would typically think of as a landscape mulch. That's the larger particle size in the composting operation, what we often term as overs. And the one on the right is what you typically think of as compost, as a soil amendment. But in this case, we're also going to be using the one on the right, the growing media, as our primary tool for erosion control. And we'll talk a little bit about that. We will combine both the one on the right, that's a ½ inch minus, to the one on the left, which is 1 to 2 inch minus, about 60%, to create blankets on slopes and what have you to provide the benefits that we're going to be talking about. So this certified compost filter media has a pH of about 5 to 8. Typically, it's closer to 7. Compost will tend to want to move everything towards neutral. Remember, I said the filter media is about 60% in the 1 to 2 inch range, and it's pathogen and weed free due to the composting process, pathogen reduction process. It is nature's filtration system. Humus, organic matter, and compost have each been well documented in the literature as effective pollution filtration devices evaluated for sediment reduction, capturing that soil particle after it's been dislodged, absorption and adsorption. The adsorption is the surface attachment of nutrients, contaminants on the surface of the compost. And in that respect, it becomes an extremely effective pollutant device and tool for us. Its primary applications are sediment control, as I mentioned. This is the coarse material now, the 1 to 2 inch range, inlet protection, and check dams, and slope interruption. The slides I'm showing you come from Filtrix International. They're the pioneers in the use of compost for stormwater management. You see the green sock, that's a sign that that product not only is Filtrix certified, it's got certified filter media in it. It's been tested. The compost growing media, however, is a finer material that's used in a number of different applications to mimic nature. So we use it both in erosion and sediment control. You'll see it's a part of any program where you're using silt socks or compost filter socks. And then we also use it for stormwater management. That has a lot to do with the volume control, the ability to absorb a tremendous amount of water, runoff water. 1 cubic foot of the half-inch minus compost will absorb 4 gallons of water, will hold that much water. Meaning, translating that to a storm event, a 1-inch rain event will, and a 1-inch blanket of this fine half-inch minus material will absorb a 1-inch rain event with 0 runoff. And that's documented by San Diego State's Erosion Control Lab. Extremely effective in managing stormwater. If we can control the volume, capture it, hold it where it is, do we have a contamination problem or a runoff problem? No. We are actually not only holding that water, we are infiltrating that water and replenishing the aquifers and the groundwater that we so terribly need to replenish. Restoration remediation, its ability to continually feed the vegetation and create that biodiversity is also a key part of compost stormwater blankets. The thickness is based on slope and 24-hour rain fitness. This is the data I'm going to show you is developed by Dr. Britt Fawcett of Filtrex International. He is the pioneer in the research, did his PhD on it. So most of what I'm showing you will be based on his research. And here he's showing that on a 4-to-1 slope, and as you get more steep, as the rainfall increases, you can get by with a 2-inch blanket on a 4-to-1, but you'll notice you go to a 1-inch blanket as the slope gets steeper because the blanket absorbs like a sponge, and the weight of the water, that water holding capacity in that blanket, will start to slough off if you get much thicker in your blanket. So a 1 to 2-inch layer of compost, half-inch minus, is where you want to be. If you get much thicker than that, the very weight and the water holding capacity of the blanket will start to roll down the slope as the slope steepness increases. Very important point. Here are some of the advantages of these blankets. You have that intimate contact with the ground, eliminating any puckering or ability for the stormwater to avoid being filtered. It also reduces your sediment loss, and the infiltration rate increases. And this also increases the germination from seed. Water discharge from slopes decreases and reduces potential sediment loss based on many studies. And in addition of organic matter improves the slope's ability to revegetate. There's your restoration and establish a permanent erosion system. So here's some examples. I'm going to go through some actual test sites. Here's a slope, gravelly clay, very typical of what we'll see all over San Diego and California, where we have a lot of valleys and canyons and what have you. Kind of rocky, probably not the best topsoil. Here is the typical application. We'll usually use a blower truck application to apply on large scale. You can do it manually, but blower trucks are the ideal way. It's the way compost blankets are typically applied. So they're applying a 1 to 2-inch layer. Here's a photo of that same site 6 to 8 weeks after the install, where we have 100% coverage. And because we have the vegetation and the seed was applied at the same time, we have excellent erosion control here with very little to no sediment release. Here it is 5 years after install. Notice the dense growth. That compost blanket has the ability to break down slowly. It's a slow release form of nutrition. And we're going to talk about tomorrow about the soil food web in more detail, but we're feeding not the plants with compost, we're feeding the microbes, which then in turn feed the soil and feed the plants, I should say, not the soil, but the plants. So here the plants have taken advantage of that organic material. The biology is really active and we're getting great growth. Here's a close-up of that contact we talk about that's so critical to hold all those soil particles and keep them from moving and being dislodged. Here's a blanket, an example, and this is a biodegradable one, and you'll see this on occasions. The problem is we're typically applying it over an uneven surface, and you will get rilling and movement of material underneath the blanket, and that can be a problem when it comes to erosion control. Not to mention the lack of slowly released nutrients coming from that blanket to continue to feed the vegetation that you want to get established on this slope. So that vegetative establishment is so critical, and having a slow release form of nutrition to feed the microbes that then in turn start to break down and release these nutrients for the developing seedlings is absolutely critical for plant establishment. Here's an example of 3 different applications or treatments, I should say. The one on your right in the screen is just the blanket alone, which will absorb again that water, break that energy and allow for infiltration. In the middle is your control with a no blanket, and you can see the typical rilling. And then on the left, you had some seed added to it and we're getting vegetation. The one on the left is ideal. The one on the right works extremely well when you can't get vegetation in there right away, because it takes that energy out of the raindrop and slows that water down, absorbs it like a sponge on the surface and allows for infiltration. Here's a project in San Diego that I was involved in on a high wall project at a quarry that had been there for many, many decades. And we first did a pilot study, and I highly recommend, my university training tells me, before I'm going to scale any project, I want to find out if we're going to get the results we want. We weren't even sure if anything would grow on this quarry because it was all very horizon sea, subsoil, very poor rock, basically. We applied a number of blankets with different seeds, and sure enough, the pilot showed that we could grow something on there. Notice the coarse material in this one was added to the slope rather than a tackifier, because the biology company that I was working with, bioremediation company, did not want to apply anything but a natural material and did not want to use and pay for the tackifier. So we added coarse material at a rate of about 30%, 1 to 2 inch, to about 70% ½ inch. And we applied it on about a 1 inch layer. So here we scaled it up. This is roughly 400 feet up. Each bench is about 100 feet. You can see the truck on the bottom there, left. That's a big trailer truck, and the blower guy is hanging off a harness on this slope. This is what it looked like after about a year. Notice a lot of rock. We have very little soil to work with a layer of that fine compost and material on the top. Here it was 2 years later when we got a little bit more rain. The seed bank started to germinate. These were all natural seeds that we had applied at the time we put the blanket on. And here's a close-up of the establishment. Notice how rocky that soil is, and that fine layer of compost was able to support this. And this is 4 years with that slope in that quarry. In fact, the quarry is still active over on the right. They're still using it for aggregate manufacturing. You can see some of the trucks on the right. But the slope itself has recovered, and we've been able to do that simply with a blanket. Now, in 1-to-1 slopes were really, and the one I just showed you was a 1-to-1. You can use the coarser material, but sometimes you want to use what they call a lockdown netting that will hold the compost in place on these very steep 1-to-1 slopes. In this case, it's a polyethylene blanket available through Filtration International, where they'll roll it on the surface, tack it down with sod staples, and then blow right over the top. It's very similar to a turf reinforcement netting. Here it is 6 to 8 weeks after the install with 85% coverage. And again, the blanket was about 2.5 inches in this case, blown over that netting. And here it is 9 months later. So in this case, you're growing turf on a slope, and there's no better erosion control for that. Let's look at blankets as compared to hydro-seeding and a silt fence application, where vegetative, this was Dr. Fawcett's work at University of Georgia, percent vegetative cover after 3 months. Note, the yard waste compost blanket had a much higher percent vegetative cover, simply because that blanket's holding that water and nurturing that seed and vegetative growth compared to a hydro-seed application. And below, what was even more interesting, I thought, was that the percent cover of weeds, because you have a thicker vegetative growth and establishment from the seeds that you planted, it crowds out, that larger stand establishment crowds out the weeds to a much greater extent. You had a much lower weed population in the compost blanket versus hydro-seeding, simply because of the accelerated vegetative establishment associated with the blanket. Here's another example of Dr. Fawcett's work, where the runoff start time, how quickly water starts to shed off a slope on a blanket on the left, top slide, and 27 minutes before we started to see any runoff occur, before you had water, complete water saturation of the blanket. And then on the hydro seed, 9 minutes. And what that results in, if you go to the next table down below, the total solid loss, is you start to see a much lower reduction, or a much greater reduction, and a lower release of solids coming off of the blanket versus a hydro seed application in this case. And with vegetation, it's almost negligible, the solid loss. Why is that? Well, as we said, compost blankets have an amazing ability to absorb water and therefore support whatever you're planting. Here's a comparison with bare soil versus this is a 4-inch rain event per hour for 1 hour, and you had bare soil at about 50, straw mulch about a little over 60, and 84% with a compost blanket, again documenting the water holding capacity. In addition to holding that water and infiltrating it, you also have that adsorption and absorption. If we're absorbing, we're holding those pollutants in place, and we are starting to degrade them. And we're also capturing a lot of that nitrogen that would run off during a normal event where you apply a hydro seed application. So in this case, these are 4 different studies. You can see Dr. Fawcett's study there in 2005 with hydro-mulch, where the total nitrogen pollution load was 58% less than the hydro-mulch, 98 on the nitrate nitrogen, more soluble, 83% on total phosphorus and soluble phosphorus, and total sediment reduction, 80%. So again, some really excellent research showing the pollutant reduction capability of a blanket versus conventional seeding with and without hydro-mulching. This material not only can handle nutrients, but as I mentioned, other contaminants like heavy metals, anywhere from 30 to 78% reduction. Bacteria, E. coli, hydrocarbons, extremely effective on hydrocarbons. Not only can it capture hydrocarbons, it can degrade it into CO2 and water due to the microbial activity on the hydrocarbons itself in the blanket. So we're not only capturing, we're not only infiltrating, we're not only holding, but we're starting to degrade those contaminants that we're capturing with a blanket and with a compost sock. Let's look at Caltrans' work over a 2-year period in Monterey County. Using compost, they used blankets and berms in this particular slide. They eventually migrated over to socks because the berms had a tendency on the slope to continually slough down the slope. So it was easier to maintain that shape of the berm. Keep in mind, a compost filter sock really is a portable berm. So they eventually replaced these berms, but this is one slope with a blanket with seed and berms on the top, and on the bottom, believe it or not, that was a BFM hydro seed application with straw wattles. And this was one rain event, 5 inches in a 24-hour period, and this is what they recorded on a very highly erosive soil. They also went ahead and had another area where they did a BFM, and they had accidentally oversprayed the compost blanket that they were evaluating on the right with the BFM. What's really interesting about this slide is that the BFM on the left without the compost was, because of the amount of rain and the erosivity, was ineffective. And note, when they applied the same material on the compost blanket, they literally got no erosion, showing the amazing ability of this compost to not only absorb water, but that intimate contact and its ability to keep those soil particles in place. Why these results matter is because Caltrans is continually increasing. This shows their increase, and it's going to continue to go up due to some of the mandates that the state is requiring throughout to divert organics. And so you can see that Caltrans is continuing to incorporate compost in their designs. And here's their summary. It accelerated the natural systems required to restore sites over this 2-year period. It built healthy soil by mimicking that natural environment. It allowed those seeds to germinate and thrive. It provided optimum vegetative growth. It protected that soil surface from splash erosion. And that high water holding capacity slowed that water down and dispersed that energy so they got no runoff, no erosion, and no pollution discharge. And that high carbon to nitrogen ratio also resulted in a low discharge of any nutrients coming off of those slopes. It had a natural biofiltration characteristic. So biomimicry and why it's important. The closer we manage landscapes to their natural design, the more we save on energy inputs, hard infrastructure, and financial expenditures. Working with nature takes advantages of these surfaces that are both free and efficient. And they are the foundation, as I mentioned earlier, of sustainable management practices, because it is what nature does naturally. It produces its own compost. What we are doing in this case, we are working with nature as a partner to take advantage of all these free and natural benefits. I shouldn't say free because there's labor costs and what have you, but a lot of services there are reduced in terms of our investment in them. Sustainable management practices represent the most sustainable option currently available to landscape contractors for managing watersheds, and when designed and implemented and maintained, will reduce that stormwater volume, the peak flow, localized flooding through natural site hydrologic restoration, and decrease the pollutant transport and improve water quality through stormwater reduction, filtration, and vegetative establishment. I'm just summarizing a lot of this. And the working with nature, the closer we manage these landscapes, the more we save on energy, required inputs, and financial expenditures. This organic matter that we're adding to the surface of soil closes that circle of organic recycling. And it takes, again, working with nature takes advantage of the services that are free and efficient that nature will provide in terms of compost capital. It can preserve that topsoil. It can purify soil water by managing nutrients, improving salinity, filtering stormwater runoff, binding pollutants in soil, and suppressing plant pathogens. It restores the water quality and in the process, the soil quality by revitalizing wetlands and invigorating depleted lands. And it remediates our soil resources by managing problem organics in contaminated soils. This is from Nora Goldstein, the editor of Biocycle magazine, the preeminent publication on the use of recycled organics in the landscape. And what she says is the primary limitation on organic use are not technical. If watershed managers, landscape contractors become enthusiastic users of organics, the only serious boundaries will be the limits of their imagination. And I think that really sums up the tremendous opportunities that lie before us that we have with working with nature to restore our watersheds, to rebalance our environment, and also to take advantage of the research that's been done even here in California. I wanted to end my whole presentation with a number of resources. This one's by Dr. David Crone, and he did a 2-year study at UC Riverside, and it was called The Impact of Compost Applications on Soil Erosion and Water Quality, and he specifically looked at remediation of fire-damaged soils with compost blankets. And what he concluded was the applications were very effective in reducing water runoff on the average of an 80% runoff volume that were measured. The compost applications were effective in reducing soil erosion. On average, total dissolved solids and suspended solids were reduced by 95, 65, and 94% respectively. I have a copy of this, would be glad to send it to anyone along with the compost blankets publication by the US EPA. And I highly recommend, if you want an excellent overview of 24 different compost-based sustainable management practices, by all means go to Forester Publications, the Sustainable Site Design Manual, and I'd be glad to share that contact with you as well. And that's it. Here's my contact information. I don't think I left much time for questions, but I am always available either by cell phone or through my email address to answer any questions you have and forward over resources to help you. So that's it, John.
Actually, Craig, we got plenty of time. You did that in a half hour.
I was thinking I started at 8. I started at 8:30. Okay, good. Well, that's even better.
Yeah, so we do have some questions, though. and I wanted to get to some of these. So first off, I see Kathleen had a question. How is moisture content linked to the effectiveness? I'm wondering how much irrigation is required to get these great results.
Excellent, excellent question. Thank you. On that blanket we put on that site in San Diego, that high wall, we actually, because we were in the middle of a drought at the time we did it, we were really concerned that we had done all that work and there was going to be no moisture to germinate anything. And we were really shooting for germination, something to grow on that slope. And so we did irrigate it. And it's a tricky question, but obviously when you're going for vegetative reestablishment, obviously supplemental irrigation, if necessary, is really critical. And I highly recommend it. Even rain for rent or some temporary irrigation system applied would be extremely effective and have worked extremely well in many cases. However, with just the blanket itself, assuming you haven't gotten any irrigation on it, that blanket's ability, as you saw from some of the Caltrans work, to hold that moisture and minimize erosion still makes these blankets very effective without vegetation. Ideally, we want to vegetate environments and landscapes, but it will work in the absence of moisture as long as your particle size is correct to be associated with the slope angle. If it's not too steep, then you can get by with a higher percentage of the fine half-inch minus. The steeper it gets, you'll want to add a little bit more coarse compost to the blend to hold it on the hill, or use a lockdown netting.
Okay, good. Kathleen, did we answer your question there? So go ahead and either unmute or type in. So Craig, I wanted to talk a little bit about, yeah, she says great. So I wanted to talk a little bit about recent times, the wildfires that we've been getting over the last couple of years. Of course, we're hearing the governor really saying that this is really a man-made environmental disaster. Whether that, you agree with that or you don't agree with that, they are definitely looking at taking steps to reduce greenhouse emissions, and the trees that are being that have been burned in these wildfires, plus the preventative work of clearing these forests, is that material. There's huge volumes of material. I think you were familiar with what was going on with the Paradise Fire, how much volume was taken out of there. Is that being composted? How is that material being handled, and where is it being applied?
Great question, and it's a huge problem and issue in California, where we do have a tremendous amount of, we'll call them bioresources, that result after a wildfire. And a lot of it's being chipped and ground and left as a mulch on the surface. They're just bringing chippers in there and grinding the material and leaving it as a blanket, if you will. Oftentimes they don't understand how to use the material. There are a number of people looking into biochar, taking that wood and literally cooking it in a very low oxygen environment through a process called pyrolysis, where they basically are producing almost like a charcoal, and then grinding that and either selling that, repurposing it in some other manner, or discarding it. But basically, all that wood that's being left on these burn sites is very, very problematic right now, and I think the state is struggling with it. Certainly a good portion of it could be brought to a compost facility and ground and incorporated into the composting process. Again, that's assuming that the end products are always going to be tested and are going to meet very scientifically validated specifications for the quality control. One of the organizations that does this, that San Pasqual Valley Soils and other composters are a part of, is the Association of Compost Producers. I happen to be a director on their board of directors. And what we do is we encourage people to get a soil, it's called the Seal of Testing Assurance through the U.S. Composting Council. And it's a set of tests that basically set a minimum standard for the quality of the compost that's being produced based on no seed germinating, no pathogens present, and it meets certain rigid requirements for the carbon nitrogen ratio, making sure that that compost is mature, that it's not leaching things into the environment that you don't want because it wasn't properly managed. The big problem with a fire is oftentimes, particularly in the Paradise Fire up north, was it wasn't just a forest that burned, it wasn't just wood, it was homes with all kinds of plastics and other materials that are very toxic. In this case, the state of California, Todd Thalheimer with Cal Recycle deployed and worked closely with Filtrex International to use compost filter socks and surround each of the burn sites to filter the heavy contaminants and heavy metals coming off each of the burn sites. So I would contact Filtrex International if you want more information on how that was done. They're the pioneers in this, technology, and it was extensively used. I believe over 1 million linear feet of compost socks were used to filter the contaminants coming off of that burn site in Paradise. And according to Todd Thalheimer, if he had had the budget, he said he would have liked to have used 3 million linear feet. It was that effective. And based on him, and this is quoting Todd, he would not use any other BMP for a burn site where you have these heavy contaminants coming off of a burned home or whatever. A forest is a little different. Typically, we don't have the financial reserves, if you will, to treat a forest, although it'd be great. And therefore, like I said, it'll be a chip and grind operation. It might be somebody coming in and doing biochar, or it may be carted off, ground up, and incorporated into a compost operation somewhere in the state.
Right. So I know logistics is one of the biggest things that the composting industry is facing. And I know just for the Paradise Fire, they had shared that every 3 days they were removing a mass equivalent to an aircraft carrier from that area. Yeah. Mostly, largely, trees, dead trees.
Right.
So, you know, this year, as at least, you know, maybe not in loss of lives, but in area, it dwarfed the Paradise. So there's all of this organic material that's having to be dealt with now. Yeah. All right. Well, other questions here. You had mentioned, you had talked about the comparison of compost blankets to hydraulic mulch. Do you have any figures as far as a cost per acre comparison of an application of a compost blanket versus applying a hydraulic mulch with maybe a hydroseed in it?
Yeah, I would say on average, a compost blanket is going to be more expensive. No doubt about it. There's more work that's involved in doing it. It's a thicker layer. It's 1 to 2 inches, where a hydroseed mulch is ground up wood fiber with guar in it and some water-soluble nutrients, as well as some dye. And so I would say a blanket's going to be probably just your initial cost. Your initial cost is probably going to be 3 to 4 times more than what it would cost you just to hydro-mulch a slope. With that in mind, however, if you look at the benefits, and particularly for very difficult areas, the benefits you derive from a compost blanket are so much greater. And in fact, a lot of the hydroseeders are starting to look at, in fact, there is a formulation where they add a compost-based material to the hydroseed mix to add some more biology to the hydroseed application. But make no mistake about it, we're talking about 2 very different types of application. One that's we synthesize using ground up wood fiber, guar, water-soluble nutrients, and one that's based on what nature would produce with all of the inherent benefits that nature provides, all those free services. So you're going to pay more for a compost blanket initially, but down the road, you might be very glad you did. I remember a project in Idaho where for 9 years they hydroseeded an area, and only until they analyzed the soil, and applied compost blankets to that site did they ever get anything to grow over almost a decade. And they spent an enormous amount of money trying to do it simply with hydro seed applications. And it wasn't until they added that organic material that the biology of the soil perked up and supported something to grow there.
Okay.
And I have a interview on that project. If anyone would like, again, email me, and I'll be glad to send you that report by the biologist that did that project.
Hey, Craig, while I ask you this last question I think we have here, go ahead and put up on your screen again your last slide with your contact information. So if somebody wants to take note of your email, they can.
Let's see, share screen.
So while you're doing that, there's another question. In this time of climate change, should the stormwater community, oops, I lost my chat. Let me, there it is. Should the stormwater community call out trainers of records and QSDs that do not promote or use sustainable BMPs in their design? Less than 1% of specifiers in California, according to this commenter, use compost blankets or compost socks in their construction SWIFT design, and instead promote rock bags or burlap wrapped fiber rolls and hydro-mulch. So maybe I think this commenter is asking for maybe a little bit more accountability or even directive from the regulatory community to just like with landfills, specify that a certain percentage be compost based. What's your thoughts on that?
Yeah, that's an excellent point, and it's a function, truthfully, of lack of education. We have not taught this. We have not taught this in our schools, how to work with nature, how to mimic nature. Most of the engineers come from a school of what we call gray infrastructure, conveying water away from streets and slopes and that, rather than infiltrating. So it's going to take a monumental effort by the state to, first of all, start to educate people on the benefits of utilizing their own bioresources in the communities and designing and integrating that. I've started doing it here in San Diego County, and it was real interesting. I got an engineer to spec it into the project, and it was a beautiful restoration project with a 1 to 2 inch blanket with some compost biodegradable socks. And eventually what happened was the hydroseeders were also alerted to the opportunity, and they convinced the biologist that it was going to make too much noise for us to bring that much material to the site. It was 2.5 acres, about 15 truckloads, and it would wake up the neighbors, and therefore she was better off going with hydroseeding, where they could bring in bales on a truck in water, and they literally flipped it from compost blankets to hydroseed. Mm-hmm. So these are the problems we're going to have. It's not just with, even when you get a designer to spec it in, if the biologists and the designers don't understand the implications of and the benefits associated with it, they can be very easily swayed to go with something that is not mimicking nature. And so I just think it's a function. There's just going to have to be a lot more education. I wish I could say otherwise, but we don't protect what we don't understand, and we don't promote what we don't understand. If we're not teaching these principles, some of the things I shared today, then it's not going to get done. And I think we have to start with education, and there has to be an investment by the state of California in not only educating the designers and the landscape architects, but also the municipalities to start demanding that this be done.
Right. And Craig, I'd like to maybe add some to that, to this commenter. I believe, we're not seeing that maybe mandated on the construction level, but it is to a certain effect being promoted on the post-construction level. So we see both in the construction general permit, but also all of the municipalities who now are required to implement low impact development and post-construction measures or condition projects with those requirements. These types of topics are being included, and where a hydro modification goal is placed, compost is a great way to meet that hydromodification goal. And we're starting to see more and more projects. You know, I know we review projects for several municipalities, and we see projects coming through for post-construction design measures. And we're seeing compost used more and more. Of course, it's in bioretention basins, but also in self-treated areas. They're putting compost down and using numbers from your studies that you presented today to prove, I think it was one of your slides you had there, about the time of, I think a time of concentration or your runoff from a hydro-mulch area versus a composted area. And those types of data can be used to demonstrate that you've met the hydromodification goal. So in a way, the requirements are there.
You bring up a real good point about post-construction. I'll tell you one application a builder considered here in San Diego. After a home is built, oftentimes it takes a while for the landscape to be done. And so you have all this bare soil around a constructed brand new home. And then the winter rains come and they splash this dirt and sediment all over the sides of the house. And then they have to come back in and power wash the house. And so what they did is they went ahead and put a compost blanket around all of the newly constructed homes on the bare soil, because they knew it would absorb the water, prevent them from having to come back and wash the houses off with all the sediment on them. And then it was able to be incorporated into the landscape after the landscape design was completed. And so the beauty of this material is not only is it a BMP for stormwater, but it becomes the SMP, a sustainable management practice for sustaining and developing the landscape after the fact. And I thought it was one of the more ingenious approaches towards the use of blankets, was just to protect the quality of the home after it was built and cover that soil wherever you can as quickly as you can with a blanket.
All right. Well, Craig, I think we're out of questions here. If anybody's got a last question, feel free to either unmute yourself or type it in. Just to remind folks, we have a couple other workshops. If you're interested in more information about compost, there are a couple more workshops. Craig's teaching a couple tomorrow, a repeat of this one in the morning. And then at noon, myths associated with compost nutrient release and stormwater runoff. Just in a couple sentences, Craig, what's that workshop about?
That one is about some of the myths associated with compost. Oftentimes it'll come up, well, we're not going to use compost because it's near a receiving body of water and we don't want to contaminate the body of water. And nothing could be further from the truth. I'm going to share with you some of the why that is, some of the differences between the different forms of nutrients and how they behave in the soil, and then some of the uses of it around bodies of water, particularly the Soils for Salmon program in the entire state of Washington has literally replenished a lot of the streams in that using, believe it or not, compost blankets and socks to clean up the water quality. And so it'll be a really, and I'm going to be talking a lot about the soil food web and how critical that is and why that's important. And again, it's looking at the way nature works versus the way we sometimes think linearly, and don't understand the complexity of this beautiful network that we call the biome.
So it sounds like it'd be a good workshop for QISPs to understand those that are having to
absolutely
maybe speccing compost at industrial facilities, but also dealing with nitrates and that type of thing.
Yes,
so
absolutely. And I'll be addressing all of those questions.
And then also tomorrow, right before that one, is John McCullough. He's going to be giving a presentation, and I know he's going to be talking about compost berms being used in place of fiber rolls. And he's actually going to show by video some examples of that. And he was actually featured at the recent Caltrans 2-day symposium on compost, just I think last month. So you will not want to miss that one as well. All right, I think that's it for questions, Craig. Just a couple last thoughts, and let's end the workshop.
Well, there's a slide with my contact information. Please don't hesitate to send me any questions or request any information. Typically, the information I'll send you will be research-based, That's just the way I work. You know, if I can't back it up with good solid science, then I really don't want to share it. So this compost blankets publication by the US EPA is excellent. I'd be glad to send you a digital copy of it. A great reference source. Filtrex International has a website where you can go into the design manual and get all of those 24 applications, compost-based applications at no cost, all on their website. So I highly encourage that. They've done a fabulous job of providing information to educate you on how to use this very, very valuable bioresource.
And by the way, if you haven't caught on, Craig is not with Filtrex anymore, but he's with San Pasqual Valley Soils. And you know what? If you want to check out a cool website, you got to see theirs. They got some pretty awesome products there, and one of the best displays of compost options I've ever seen. So
right, and for any of you out in Southern California, in the San Diego area, if you'd like to come by, give me a call on my cell number. I'd be glad to give you a tour of the soils facility. We have 300 acres of alfalfa. We have the largest dairy, one of only 2 remaining in San Diego. Glad to share with you a little bit of San Diego agriculture and the San Pasqual Valley Agricultural Preserve.
All right, Craig. All right, you guys have a good morning. Thank you for joining this workshop, and we'll see you at one of the next ones.
Thank you all. Appreciate you joining.